Hey, what's up, guys? Chung here again. So this time I want to talk about this LeetCode problem here. Number 1438, longest continuous subarray with absolute diff less than or equal to limit. All right. So you're given like an integers of arrays, right? And you need to return the longest non-empty subarray such that the absolute difference between any two elements in this subarray is less than or equal to the limit here. So for example here, so with the array 8, 2, 4, 7, so the longest subarray uh, for not exceeding the limit 4 is 2, right? Basically, so from 8 to 2 is 6, right? That's not so 8 is itself. 2 is also an element of it. The difference with itself is 0, which means the single element is always a subarray, right? A valid subarray. In this case, the difference between 8 and 2 is 6. And for 4 and 4, this is correct, right? How about from 2 to 7? No, right? Because from 2 to 7, the difference between 2 and 7 is 5, which is greater than the limits here, right? And then we have to shrink it back to 4. And when it comes to 4, then it's a valid array again because the difference between 4 and 7 is 3, right? So in the end, the final answer is 2. So as you guys can probably see in this one, so with the array here, right? Array I to j. So how can we check if, let's say, for example, if this array from I to j is a valid array or not, right? We need to check, basically, then we need to know what's the maximum value in this range and the minimum value, right? Minimum and the maximum, right? Because if the maximum and the minimum value between this range is within the limit range here, then we know, okay, this array is a valid because any subarrays, any combinations of this array will not be exceeding the limit, right? And once we have this thing here, if there's a way we can know what's the minimum and maximum value in the range of I to j, right? Then we can simply do a left and right pointer, right? Basically, every time we move the right pointer, we move the right pointer forward, and we check. Okay, so if the current array uh, satisfies this condition, right? If it is, and then okay, we know we find like a, and then in the end, if it satisfies that condition, then we just uh, compare the current length of the array with our final answer, right? And if it doesn't, then we try to shrink. We will be try to shrink the left pointer, right? Until the minimum and the maximum are within the limits of that subarray, right? I mean, the easiest way will be we simply just loop through everything, right? We have two for loops, right? Every time we have like a loop. Basically, we get all the possible subarrays, and then we just get the minimum and the maximum, and then we compare if the maximum minus minimum is within the range of limits, then that's a valid one, right? But for this problem, there's an issue here. We cannot do that because as you can see the constraints here. It's the the length of the numbers is 10 to the power of 5. So if we have like if we do like a nested for loop to get all the combinations of a subarrays, that's going to be an n square, right? So in this case, it's going to be 10 to the times of 10. it will pi TLE TLE. So we have to find, so basically we need to find like a better way of maintaining basically the range, basically the minimum and the maximum for the range of I and j, right? So how can we find do it better to maintain the minimum and maximum range for I and j, right? If we for the regular, for the like traditional way, we just do a minimum and maximum, and we pass in this like uh we pass the start and end, right? And then we just get the minimum and the maximum. But that will also be a O(n) time, right? It's also a time consuming uh, operation. So the way we're using here is we're gonna use the increasing queue and the decreasing queue to maintain the minimum and the maximum value. So for the increasing queue here, right? So sorry, for decreasing queue, decreasing queue, and increasing queue. So the decreasing queue, it's like basically the first element will be the maximum value, right? And for the increasing queue, the first element will be the minimum value, right? And so why we're using this like decreasing queue and to store that, right? Because let's for example, let's say the increasing queue here. Let's say the increasing queue is like and sorry, so to maintain the decreasing queue and the increasing queue, basically every time when the right pointer moves to a new element, will be basically updates the decreasing queue and increasing queue, right? For example, if the decreasing queue is like 10, 8, 6, and 4, right? And increasing queue basically is the same. It's gonna be whatever it is. Sorry. So for the decreasing queue, the reason we're using this decreasing queue to maintain the current the what is that the maximum value of within the range I and j, right? Because let's say if the current element is 10 here, right? The maximum is 10, right? And then we and then we're trying to shrink. We're trying to shrink we're trying to shrink the I and j. We're trying to shrink the left pointer, which is I, right? Basically, every time when we shrink the I and j, right? So when we see, okay, so the maximum minus the minimum is greater than the limits, then that's when we need to shrink the left pointer, right? And every time when we shrink the left pointers, we need to update. Basically, we need to update our minimum and the maximum values, right? But how to do that? We do it. We update our minimum and maximum value by updating this decrease queue and increasing queue. So and basically every time when we shrink the I here, right? We know, okay, basically we're gonna remove this I from our array here, right? And then what do? We check, right? We check the if this element we're going to remove is either the minimum value or the maximum value, right? Okay, so basically if this one is okay, so if the element that we're removing is not either the minimum or the maximum element, then it will not affect our check condition, right? So basically it will not give us like a smaller a smaller range here between the minimum and maximum. We just keep shrinking the I, right? Until we meet either the minimum or the maximum element, right? Then we simply pop it from the this queue. And let's say, for example, let's say if we see a 10 somewhere, all right? So let's say we move I to the right, like to somewhere here, right? Somewhere here, and then this current one is 10. Okay, then we know, okay, 10 is the one so we're gonna pop this thing up, right? But after popping these things up, right, we want to know, okay, from here to J, what's our maximum, like value, right? After popping the 10 here, then it's gonna be 8, which will be the next one. Basically, it will be our new head for our decreasing queue, right? So for the decreasing queue, as you guys can see, so from left to right, right? From left to right, the index is always increasing. Actually, we can either save the index or the actual value into this decreasing queue, but in this case, we're just storing the values here. So basically, you know um, this 8, right? Basically, so basically anything so any numbers here, basically in this decreasing queue tells us this 8 appears after 10, right? And this 6 appears after 8, and 4 appears after 6. And and you can think of this thing, since we said we already defined this, like so this decreasing queue stores the current, the minimum and the maximum from I to J, right? So you can think of the starting point is I, and on this side is until J, right? Every time if we move the I forward, right? Let's say, for example, they're like 1, 3, 1, 3, 2, right? Let's say there's some like smaller number in between the 8 and 6, right? And let's say we move this I from 8 forward, right? The moment we remove 8, the moment we remove 8 from this decreasing queue, so the next highest, so basically the current, not the high, the current maximum value from this I to J will become 6, right? So that's why in this like decreasing queue, we don't care about every time, and once we see a 6 here, right, we just remove everything we have seen so far in this queue, and we just let's see, I think this is not a good example here, so it's gonna be 5, 3, 2, right? So okay, and assuming, right, when we maintaining this decreasing queue here, we had this like 8, 5, 3, 2, and then we see a 6, right? And then if we simply remove everything, it's smaller than this, and we just remove these things, right? Yeah, basically I'm trying to explain why we're using this decreasing queue to maintain the maximum value in the range of I and j, right? So like I said, if we move this I forward, right, it's basically if we pop this 8, the current 8 out of the decreasing queue, and then immediately we have this 6, right? We have this 6 here, and and that's how we know what's gonna be the next uh, next biggest max number, right? After removing the current I. Same thing for the increasing queue. That's basically every time once we remove the current smallest number, then we know, okay, what's going to be our next smallest number, right? And yes, so we're just using the basically we're just using the, I think I'm repeating myself, but I'm just trying to get also trying to talk to myself, trying to explain this thing clear to myself as well. Mm, basically every time if we check as long as if the current maximum and between the current maximum and the minimum the difference is greater than limit, then we try to shrink the left pointer. And every time we shrink the left pointers, we'll be also updating our current uh, the minimum and the maximum value until it's within the range, right? And then we move the right pointer forward again until we have traversed the whole uh the whole string, right? Okay, so let's try to code this problem. I believe we already talked a lot. So first, like I said, gonna have a decrease queue, right? Increase decrease queue, decrease queue. Since we're going to pop it from the left, and we're gonna have like a dequeue and increase queue, right? So this thing this is gonna be the current stores the current max candidates, right? Stores current minimum candidates, all right? And then first we need the answer here, and then we also need a left pointer, right? Left equals pointer equals 0, and the right pointer actually is we're gonna use a for loop, right? So we're gonna use the for loop to I'm gonna use the right to um, in enumerate, okay? Enumerate, since we're going to use both the number and the index here, nums, right? So every time when we move the right pointers, we will update our decrease queue and increase queue, right? So for the decrease queue, while it's not empty and the number is greater than the last element in this decrease queue, right? We simply remove it. We simply remove the decrease queue. We do a pop, right? And in the end, we just do a decrease queue dot append this number, right? Same thing for the increase queue, and num in this case num is smaller, right? Smaller than the increase queue minus one. We do the same thing. We pop that whatever it's smaller than the current numbers, and then in the end we just do an increase queue dot append number, right? So now since we have the updated mix minimum and maximum number, right? We just compare. We compare if since the first element of the decreasing queue will be the current maximum number, and the first element in the increase queue will be the current minimum number. So we check, right? Basically, we check, and while the decrease queue dot zero minus increase queue dot zero it's greater than the limit, right? If it's a limit, then we know if it's greater than the limit, then we know, okay, so we have to move our left pointer to the right side, right? So by moving that, right, by moving the left pointer side, we also need to update the queues here, right? How, right? Basically, we check if if this if the element we're going to remove now is what is either one of the biggest number or the smallest number, right? If this thing equals to the number left, right? We simply do a this uh, pop left, right? Because since we're going to remove the maximum, because the current element we're going to remove, we're going to move away from our sliding window is the maximum one, right? Same thing for the for the minimum value here, right? 0 equals to the number. Basically, we need to update of the both of the queues here, and then like I said, we simply move this one forward, right? So basically, after removing any of this, like the maximum value and the minimum values, we might get a different range here, right? And that may uh, fall into this range. But if it's still if the difference is still greater than the limit, we just keep moving the left pointer, right, until we satisfy this condition, right? And once we satisfy this condition here, we do an answer, right? We do an answer here. Once we know, okay, so the current range from left to right is a valid substring, a subarray, then we just update our answer here by comparing the answer with the current right and left, right, and plus one, okay, right. In the end, we simply return the answer. So I think that's it. Uh, nums. Cool. So yeah, it passed. Mm, yeah, I think it took me a long time to get to this point where I kind of understand this problem. It's a very like if we don't have this like constraints here with this like a huge input numbers, we can simply do a minimum and a maximum to get this minimum and maximum values, right? So we don't have to use all this kind of like DQs and increasing Q and decreasing Qs. But since we have this huge, kind of a huge like input size, so we have to use like a more efficient data structure because, yeah, sorry, let's take a look at the what's going to be the time complexity and the space complexity for this problem, right? So for the time complexity, we have n here, right? So we move from left to right, so the first one is n. And then inside we update the queues, right? So okay, so what's the total operations for the DQ and the InQ? It's also n, right? So plus n, because we'll be inserting and popping. Okay, so it's going to be a amortized analysis, right? So let's say, for example, the DQ, right? So let's do a little bit analysis here. So for the DQ, let's say for the worst case, sorry, uh, for the for the best case, yeah, for the best case is that we always append, right? We always append, and we'll never pop, right? So in that case, the total the total operations on in this decreasing queue will be n, right? That's the best case, right? So we only need to we always do a append to this queue. What's the worst case? So the worst case is every time we see like we see some new numbers, we always pop first, and then we append, right? So the best case is n, and the worst case is 2n, right? Basically, with each numbers, every time we do a pop and then we do append. But even though, so between this worst case and best case, so, and the, the amortized like time complexity for this queue, the queue operation is also n, right? And same thing for the in queue and dq. Basically, it's going to be for this one, it's going to be n plus uh n plus n, right? So, and here it's just yeah, I think here we're gonna be assuming it's like a O1 time complexity here, O1 time. So that's why, so the total time for this like code is 3n, which is also On, right? How about space? Space is like it's obvious, right? 2n, which will be On as well, right? So that's why we from n square we move it, we we reduce it down to On just because of this like increasing queue and decreasing queue for the to help us track the minimum and the maximum value within the range. And okay, so what else uh, can we learn from here? Yeah, I think there's some other similar problems in LeetCode. I think I'm also going to check out those similar problems to help me further understand this, like the this queue, the increasing queue and decreasing queue, to track the minimum and the and the maximum values. I think there are some other use for this decreasing queue and then increasing queues, but I have to do more like problems to help me familiarize this data structure. But for this problem, so basically we use that thing to track the minimum and the maximum value in the range, in the current range. And every time when we try to move this like pointers, we update our range. We update the minimum and the maximum value of the current range. Okay, cool. I think I've talked enough, and I hope you guys can learn something from this problem. At least I did. And yeah, cool. Stay tuned, and thank you so much for watching the video. And see you guys soon. Bye bye.